Gate Land, what's popping? Yo, man, what's up? What's popping? Daryl Banks, what's good in the building? What's popping? How y'all doing this morning? Can y'all hear me? What's up? Ali, all the way out in the UK, what's good? Vela, what's popping? Number one, good evening. Good evening, where you at? Yo, put your location in the chat. Put your area code, country code, where you at? In the building, early. Networks and breakfast. I got my mint tea on deck. I'm sitting here trying to set up my device, trying to figure out what's going on so we can get it in this morning. So there is no 65. So maybe there's 66. All right, let's try 66. So big T. Let's do it. No. So we need to do that at 66. And let's do a no 65. No 65. Come back here and do a telnet 66. Boom. Look at that. That ain't gonna work. Shift X. Let's try it again. What? Is it because I got denied? Try one more time. I just did it. Session. Let's see. Show session. What's poppin'? And let's disconnect that session. So disconnect. Yo, I'm waiting for everybody to get online. Give them a couple minutes while I get my stuff going. Let's see. One. Closing connection. Telnet. Still refused. Still refused. Let me do a try this again. Show host. Alright. Man, I just created them. What happened? Alright, so let's do 66. Boom. And now let's try it. I don't know why I didn't create it last time. Show host. Alright, so it's there. So maybe it's not 66. Let's try it one more time. Let me in. Let me in the building, son. Show IP interface brief. Yeah, it's still up. So let's try. So we know that 73 should work. Those ain't turned on either. Oh, okay. Cool. That one's on though. Make sure it's plugged in. So let's try 73. Yeah, that should let me in. Boom. Alright. Hey yo, so what you're looking at now is I got a 2800 router that I actually set up as a terminal server to be able to console into all my devices. The last time we did a live stream, I had to move my cables around and I'm like, yo, this is whack. So what I did was, let's get on Google. So if you look up, let me see, terminal, Cisco terminal server or access server, whatever you want to call it. We'll just pull this up. And we got images. So basically, I had something that looks like, where is it at? It looks like this. So on eBay, I had something that looks like this, but it's a 2800. This looks like it might be, what, a 2621 or something. And I have what you call an async card in there. Mine actually has 4 slots, but I have one, and then you get what you call an octal cable. And so this octal cable, I don't think it's serial. I guess it's octal. I don't know what type of connection. Looks like parallel, but it's not. I don't think it's parallel either. So you plug that in, and then at the end of this, it has about 8 cables coming out, and they're actually rollover cables to go into console ports. And so you set up reverse telnet or reverse SSH. And the way you set that up, I got this device booting up, so the way you set that up is by doing this. So there's a couple of things you have to do, but I'll show you. So begin line. what you have to do is set up your line connection for Telnet SSH, log in local, so you can actually SSH into your loopback on your device. So on this 2800 router, I actually have a loopback set up so I can telnet into this address, and the way I do that is by the port number. So if I do a show run pipe include IP host, and I'll probably make a video on this. If you're interested in seeing how to set this up in your home lab, let me know in the chat, and I'll go back and I'll go walk through step by step on how you do this. And so what I do is I log into the global configuration mode, and from there what I do is this IP host command. I do the IP host, then I name whatever I wanted to name it, and then the port number. So it has to be 2000 plus the line number. So if you do show line, you'll see your different line numbers here. So you have to pick one of these numbers that aligns with the cable, and it's tricky. You just have to kind of play with it to figure out how it works, and then you assign this loopback IP address. And so when you log into the device, you're going to do something like telnet whatever port. All right, here we go. Here we go. I still put the wrong name in. It should just give me another. It ain't going to give me another chance. See, that's the problem. All right, so now I got to disconnect it again because I keep putting the wrong info in it. So let me disconnect this line. Disconnect one. Confirm. Let me do a show session. Make sure I disconnect all of them. And I need to disconnect two as well. Boom. So give it a minute. Let me get up with this chat, man. Where y'all coming from? What's popping? George, what's up, family? Maddox in the building. What's up, Christian? What's popping, family? Daryl says, watching from my phone, about to jump on my laptop. Hey, salute, bro. Appreciate you coming on. Holla, holla, holla. What's up? What's in the building? Gate Land, Sweden in the building. Ernest, what's up, family? Mark, what's good? I'm starting to learn CLI. Hey, CLI is a great thing. Like, I don't know how long it's going to be around, but right now, you know, I love being in the CLI. No, I'm not. Hey, Ali, I'm not using Putty, bro. On this system, I'm actually using Secure CRT. I did a video of it. Let me see. Let's hop on my YouTube and youtube.com labeveryday, and I'll put a link in the chat to Secure CRT and how I have it set up and stuff. And here we go. Check it out. Shout out to
if you manage a team, you have to try.
Yeah, I don't feel like hearing your advertisement, but check that out, Ali. That'll show you how I have my Secure CRT set up and all that good stuff. Mark, it says, I love how you can put security on individual VLANs. Yeah, hey man, you can do so much, Mark. I'm gonna try and dive into some of that today. Rob Evers. Rob, what's up, family? Hey, shout out to Rob. Everybody tell Rob what's good. He's a fellow co-worker, senior network engineer in the building. Just started. Shout out to you, Rob, man. Thanks for tuning in, bro. George, what's popping? All the way from Berlin. What's good? Francisco. Shout out from KC. Hey, Francisco, I'm in KC. What's good? 816 in the building. Congrats on that CCNA, bro. Congrats. Celebrate. Celebrate this weekend with your family, with your loved ones, with your friends, all that. Turn all the way up. Hey, no problem, Ali. It also says router on the stick is used in production. It's still used in. Hey, thanks, Daryl. I appreciate that, bro. You got a question? So, Astro Pogas. The question is router on the stick still used in production networks? Yes. You have to understand that router on the stick is basically like how your home is set up. It's one router that has a switch inside that hands out IP addresses, and basically everybody's house is pretty much a router on the stick. But the only thing is you only really have one VLAN. But if you was to get a switch, you can actually separate and configure it to where it functions like a router on the stick. You would probably have to set up private VLANs or something. But in small networks, buying multiple routers really doesn't make sense. So creating sub interfaces on either a router or an ASA allows you that capability to be able to support multiple VLANs and segregate networks and still provide that functionality that you need. So yes, it's still used in a production environment. And then a lot of organizations have like what you call a collapsed core. So you'll have like a 6500 switch or a 4500 switch or something like that, to where it's one switch that operates at layer 2 and layer 3. It does all the switching for your VLANs, for like VLAN 1, VLAN 10 or whatever. But then it also provides the default gateway functionality for the organization as well. And there's a lot of companies that still run like that today. And that's essentially a router on a stick. So let's see. Royal, what's popping? It can be small environments, of course. Yep. Yeah. Large enterprises, I would say they should not ever use it, but depending on how and who designed it, it can still be in place. And it depends on what you call large too. If you're talking Google, nah. If you're talking Cisco, no. But depending on what you call large. Francisco, it says, Josh, what's up, family? Finally caught you live from Australia. What time is it in Australia, family? That's what's up. Shout out to you. Marky says, is it true you can turn off router features on a router and use it as a switch? Yeah. Hold on. So, depending on the router, depending on the line card that's in it, it does have switch functionality. In this what we're going to discuss today, I'm actually going to use a router like a PC, where it's not going to do any router. It's just going to function like a PC. What does your PC do? It uses an IP address to communicate with the network. That's pretty much what it does. Well, not, layer 1, layer 2, layer 3. So I'm going to do the same thing with a router. I'm going to show you how to do that too. Now today, this is the design we're actually going to go through. The goal for me that I want to talk about today is basically static routing in ACLs. If you hop on my Twitter, and I'll put the link to my Twitter in the chat, you can download this design. I'll put it on my Twitter. So that way, if you're looking for how to follow along, how to lab it up. So a quick discussion on what we're going to talk about. If anybody got any questions, let me know. I'm going to give y'all like 1 more minute before I start talking about this design and getting into my lab. So, and actually, let me try and get into this session I've been trying to get into for a minute. Telnet, type my name. Oh, no wonder the D. My D ain't working right. What's going on? Hold on. D works there. D's not. Yo. Let me disconnect this connection. And before I do, hold on. Stand by, my friend. All right, cool. Cool. We should be good. Alright, so is this NetSim? No. Is it a wireless keyboard? Or are you using a laptop? I'm using a bunch of stuff, bro. But no, it's not a wireless keyboard. It's a wired keyboard. I'm actually using. It's my keyboard. Alright, so let's talk about this design before we get into the lab and all that stuff. So if you look at this design, so what you have, this could be either 2 different customers, or like this customer A and customer B, or this could be customer A that has multiple sites. You can't really say it's dual home because they don't have connection in here, but we'll talk about it in another video. Let's just call this customer A and customer B. you have router 1, router 2, router 3. What we're going to do is assign a loopback on router 1 for 1.1.1, a loopback on router 2 for 2.2.2, and this will simulate our internet connection or ISP connection. And on our, this should be router 2. I should have renamed it. That's my bad. So this should be router 3. And the IP address should be 3.3.3. You know what? Let me pull up Vizio and put out the right thing. That will help. I did this early this morning, like 4:30 this morning. So that's my bad. So I'm going to redo this again and repost it on Twitter. So that way you'll have the right stuff and won't be all confused. 3.3.3. And we'll change that to R3. Make sure we don't need to change anything else. And this is the network. We're good. Let's actually get the IP address here so you'll know this is .1 for here. .1. Smooth that up. Let's see. Can you all see that? What I'm doing? I'll make sure y'all can see what I'm doing in my Vizio. Get used to using Vizio. Creating designs and stuff. Alright, so for this PC network over here, PCA and PCB, we can actually name that too while we're in here. Alright, so this is going to be the default gateway for both of these. So this is PCA and smooth that down there, and we'll call this PCB. So PC, so that way we'll know what we're talking about in the video. So PCB, boom, good to go. And I'm actually gonna retweet this out real quick, all that good stuff, and we should be good. So let me save that. Let me save it as PNG. Network design. I got a lot of designs in here. And basic PNG. And boom. Boom. And I'll retweet this out. Give me 1 minute to retweet this out. Cisco validated the designs. While we're in here, this is something you should get used to looking up. I'll put this in the chat as well. If you're wondering how things are actually designed, get used to checking out the Cisco validated design page. It's a really helpful resource on how Cisco recommends you configure your designs and all that good stuff. And let's see. And as well, while you're waiting on me to tweet this out again, if you could share this out on your social medias, that would be great. Appreciate y'all's support. You all are everything, and I mean that for real. So I am sending this out now, and boom, boom, we are tweeted out. But man, one of them things. All right, so we'll close that out. We'll open up another one, and once we do that, we'll be good to go and rocking and rolling and back on course. So, boom. All right, so let me catch up with y'all one more time. Like I said, this is gonna be on my Twitter. So if you hop on my Twitter, labeveryday, link in the description, and link in the chat as well. So check that out. But I was talking about the Cisco validated design, which you will come here. Any type of design that you're actually wondering about, how it's actually configured, come here, check it out. It's a great resource. Another great resource that I recommend that you get used to using is the Cisco Feature Navigator. If you have, let's say, a 2960 or 3750 or some type of switch or router in your device, and you're wondering what features that it has, is let's say you're trying to configure SSH, but it's not configuring. What you can do is take your iOS, go to the Cisco Feature Navigator, and determine what your software features are. So you click research software or whatever, and then you come in here and you tell it, all right, I have iOS, or do you have CatOS, Nexus OS, iOS XR? You tell it iOS, and then you come in here and you pick out what you have, and then you just go through the steps of the type you have. It's going to ask you what platform you have it on, and then after you go through all of that, now is it universal? Let's say it's the universal security, and now it's going to tell you all the features that your device has, or your iOS has. So if you need to upgrade your license, this will let you know, okay, your license is LAN based or IP services or whatever, IP base. And if it doesn't support routing, this is going to let you know why you can't do the things you want to do with your iOS device. All right, so I'm going to share this as well. Cisco Feature Navigator. Remember that this is something that you'll actually have to research on your job as a network engineer. So understanding that is very important. Let me say what's up to the chat before we get back to the design. And let's see. It's early. At what point would you migrate from ACLs to a dedicated firewall? You have to understand that that's what firewalls do. So if it's bogging down your router, if it's causing issues with your router, it's time to get a firewall, move those ACLs to a firewall. So that's what it actually, firewalls do. You know what I mean? Routers route packets, and firewalls control access. You get what I'm saying? So, I mean, in my opinion, if you're trying to manage access, it's probably easier and more efficient to do it on a firewall than it is to do it on a router. It's painful to do it on the router too. It's painful as heck. Let's see. George, it says, is this the time you go live every day? I don't want to miss any of these. Every Saturday, 6 a.m., I'm going to go live, and we're going to be labbing, talking about networks, giving tips, sharing information. I'm going to be learning from y'all. Y'all learn from me, and all that good stuff. Nice. Showing up the J's again. You silly. You have 2 routers, too. Which workers? Good day from Maryland. Shout out to Maryland. Rob, he says, right on the stick is still used in Pride and all enterprise orders I work. Hey, see, Rob's telling you right there, and he's came from a couple large environments as well, and he's telling you the router on the stick, it is still, I mean, it works and it's convenient and it saves you money. Mark, can you show us how to set up GNS3? I actually got a video on that too. And check out David Bumble. I think he has a lot of GNS3 videos as well. So, which worker? Now is that with DMVPN? I got confused with Vizio. I thought it was something like GNS3. Nah, Vizio. Just yeah. I got a video on Vizio too. I'll share that in the description of this video. I'm not gonna go to that now. What's up, Hooded? What's poppin'? Great info, man. Hey, thanks, Earl. I appreciate that. They also provided stateful inspection. All right, y'all. What's up, TravX? What's good? Let's get back to this. So now I have this good and it's shared out on Twitter correctly. We're good to go. Let's talk about this design. So basic design. When you think of CCNA material, this is basically what you're going to see. The only difference in the design on CCNA is that you'll have some type of ether channel in between here. You'll have an ether channel functionality in between here where you have to configure that as well in order to have these as HSRP. Or you can have a connection in between here to have HSRP, which is the hot standby routing protocol or whatever. Hot standby redundancy protocol. HSRP, hot standby redundancy protocol for redundancy. So basically, when you have your default gateway, if router 1 goes down, you still have connectivity to router 3. And if router 3 goes down, you still have connectivity to router 1 to be able to route to the internet or wherever your data center or whatever is in your organization. But in this design, we're going to start with the basics. We have company A, company B. The goal in this design is to have PCA talk to PCB. They're on 2 separate networks, as you can see, and they cross multiple broadcast domains. So When we talk broadcast domain, this right here is one broadcast domain. The 192.168.1.0, one broadcast domain. Everything in this /24, which is 254 usable addresses, I believe. Yeah, 254 usable addresses. They can communicate in that one broadcast domain. Now, PCB, its broadcast domain, 192.168.2.0. Everything in that broadcast domain can communicate. Now, in order for PCA to talk to PCB, it has to go from this broadcast domain to this network, to this network, to this network in order to get there. Now, what does that mean? R3 is going to know about R2. You're going to have some type of routing to say, okay, in order for me to get to R1, I need to go to R2. And in order for me to get to PCA, I'm going to have to go to R2. And then R2 is going to say, okay, in order for me to get to PCA, I'm going to have to go to R1. And then R1 is going to have to say, because what's going to happen, if you configure, let's say, we're talking in this video about connecting PCB in order to talk to PCA. So we're configuring static routing to say PC3. In order for you to get to R1, the internet and PCA, I need you to go to R2. And then R2 is going to say, yeah, okay, you want me to send these packets where? Because it's not going to know how to get to this network. So you're going to have to configure a static route on here to say, all right, in order for me to get to PCA, I'm going to have to go to R1. Now, what'll happen is R2 will send the packets to R1, and then R1 will be like, cool, I got your information. Now what I'm going to do with it? Because it's coming from here. So he's going to have to say, all right, I need to know how to get to R3. So R1, you got to configure a static route to say, okay, static route to go to R2. And then from R2 is like, all right, you want me to go to PCB? How am I going to do that? And you configure a static route to go to R3. And then you'll have all your routing configured. That's static routing in a nutshell. So if we were to go into my lab and I log on to my terminal server, and like I told you, I have multiple devices configured. So if I do a show host, and the first one we want to go into is R1. So let's go into R1. We're going to telnet, and then 192.168.33.1. And then we're going to do, let me see, R1 is 2071. Log in with my info, and we're in R1. Now let's do a show IP interface brief to show the configurations on this device, and there are no configurations. So if we look at our network diagram, we need to configure a loopback. Loopback address is 1.1.1. We're going to come in here. Let's make sure we don't have no configuration. Let's verify the configuration before we do anything. So we verified that there's no configuration IP address wise on these interfaces, but the easiest way to do that is just do a show run, which shows us the running configuration. So we're going through here. I already configured a host name. Otherwise, the host name would be host name by default. And we can see there's no ACLs assigned here. The interfaces are shut down. This IP address is actually set up for DHCP, which I think I set that up in my last one, so we don't have to worry about that. All right, cool. Now, so there's no configurations on here. Let's go in here and configure a loopback. The way you do that is interface. Let's type it all out so you actually know what we're doing. To configure any of the interfaces that we talk about, you type the word interface, then the word loopback. And so since this is R1, we're going to tell this 1.1.1, and then this is /32, meaning that it's the only address, oops, my bad, interface loop back, and then you give it a number. I'm sitting here thinking and talking at the same time. That's hard to do. All right, so now we give it the 1.1.1, and then 255.255. And so now, if we go back and do a show IP interface brief, you'll see the IP address is configured. And so now we also have to configure an IP address on this interface here, which is connected to R2. And it's a serial interface, which I need to determine which card we are. So let's do a show inventory to determine where we are. And I believe the HWIC is the one we want. So it should be card, this one. It should be this one right here, I think. Config T, let's go into interface, serial 0/0. And let's give it an IP address of 10.1.1. Since it's 1 or R1, and we're going to get that 252, which is 4 IP addresses in that subnet range, but only 2 usable. 1 network ID and 1 broadcast. And then we'll do a no shut. I think that's the right interface. I hope that's the right interface. And this actually show interface serial. That'll let us know what it is. Yeah, I think that's it. That's HLDC. Yeah, that should be it. Because if we look at this one, it should say like T1 or something. Yeah, so the way so I have a T1 card in here. If you do a show interface on the interface, show interface on the interface, you'll see what type of hardware is installed. And so as you can see, integrated T1, CSU, DSU, that's going to let me know that's not the one I want. The one I want is actually the serial card. So that's good to go. So we have an IP address on there. Let's do a show IP interface brief again. And we see that's good, but it's down. So this is up. A loopback, as soon as you initialize a loopback interface, it's going to, and assign an IP address, is going to be up. Now, can anybody tell me why I assigned a IP address on serial 0/0 and it says down? I'm going to check the chat real quick. Who got me? What's up? Where y'all at? Y'all sleep? Okay, so Vela says encapsulation not matching. Anybody else? Clock rate. Clock rate? Okay. Setting up labs over here. I see you. What is the question? The question is, I configured an IP address on serial 0/0 and I did a no shut, which should bring the interface up, but it's down. No cable attached. Hey, shout out to No Phone. So there could be no cable to that, meaning there's no layer 1 connectivity on this device. So that's why it's down. No layer 1 connectivity. So in other words, either the cable's not plugged in or the other side is shut down. But there's basically no physical connection. Shout out to Watcher Networks. Layer 1. There you go. Great answer, Larry. Everybody's giving great answer, but it's a layer 1 issue. Bottom line, if you see this right here, status down, it's a layer 1 issue. Now, if this says up and this is down, that's a layer 2 issue. So this is layer 1, this is layer 2. Let's say that again. Layer 1, layer 2, layer 3. All right, so we got the serial interface configured. We have the loopback interface configured. Here and here, we have both of those configured. Now we have to configure the LAN connection to PCA. And let's see, let's configure that with, let's see, which port is that? Let me see. Router 1. That's fast Ethernet 0/0. All right, so let's go. Config T. Go into global configuration mode. Interface. Fast Ethernet 0/1. And we'll give it an IP address. And we'll say 192. Say .1.1 255.255. and we'll do a no shut. Well, I got a lot of stuff connected to this. I want to make sure I don't cause any issues. Let me unplug all this stuff from here. Everything but what I need. So, cool. And we'll do a no shut, and that's good to go. Now, one thing I didn't mention, and I think you have to understand, and I'm going to go back and do it. So, whenever you're configuring interfaces on a network device, it's always good to do a description. And I'll show you why here in a minute. But I'm going to go ahead and give this a description, so that way every time we log into a device and we do a show description or look at the show running configuration or anything that we need to determine what's connected to that port, we'll know what's actually assigned to that port. So let's actually put a description on here, and let's call this connection to let's call it PCA. And PCA. So connection PCA. Boom. And now let's go back into the other interface, serial 0/0, and let's call this WAN connection. Or connection to ISP. Let's call it that. So description, if I can type, connection to ISP. Boom. And that's good. And loopback, it's a loopback. So you really don't have to put a description on that because it's self-explanatory. So we do a show interface description, show interface, and a description. Now, right from the command line on privilege exec mode, we can actually see, all right, so this is what we have configured. And this is up. So we have connection to PCA now, but it's down. So we have that configured. We're good to go. One more thing, I'm going to go ahead and configure a... Now, we'll say that for another one. So let's just keep it simple. We'll do a write mail or copy run start. Either one. Write mail, copy run start. Copy the running configuration, which we're on right now. All the changes that we made right now is in the running configuration. If we don't save them, it's going to load the startup configuration, and it's going to look like a default device. So we have to copy the running configuration to the startup configuration, which is the same thing as doing the write mail. Cool. So we have this device basically configured just like this design here. So R1 is configured. Now let's go down to PCA and get that configured real quick to see if we have connectivity before we move on. So what I need to do is figure out how to connect the PCA. So let me do a show host. All right, so is that PCA or PCB? So yeah, that's gonna be PCA. So let's go in here and do a config T, IP host, and let's try 2067 IP host, and what's the command? PCA 2067 192.168.33.1. Alright, so let's try to telnet to it and see if we can get to it. 192.168.33.1, and then the port is 2067. And let's see if we can get in. So we know that's not working. Alright, so let's try 2066 again. Yo, this router just might have an issue. Like, you know what? We know what does work. So let's do this. Let's do another show host. And let's take switch 1, which is connected to PC1. And let's just give that an address because we know we can get into that. So this is going to be simulated. Weird. But you'll understand once I'm done. Cool. Ran the switch. And let's call this. Let's just call this. Let's change the host name. Let's call this PCA. So host name is going to be PCA. And then we'll give this a default gateway. So when you configure a computer, you have to give it a default gateway. So we'll give it a default gateway of IP default. If I can spell default gateway, and let's give it 192.168.1.1 interface VLAN 1, and we'll give this an IP address of 192.168.1. Let's call it 2. Boom. Configure that. Give it a minute. And no shut. No shutter. No shutter. Alright, now let's see if we can ping the default gate. Hold on. Before we go further, I'm going to have to remove these console login messages. To do that, you go to line count 0, login synchronous. This is something you need to know for your CCNT, I believe, is whenever you see these login messages, it kind of interrupts what you're doing. In order to turn that off, you log into the console and do a login synchronous, or whatever it is. I've never heard it pronounced right. All right, and now we're going to ping the default gateway. So .1.1 and see if we can ping. Ping. So we have connectivity to R1. Let's see if we can ping that loopback. Boom. We can ping the loopback. Let's see if we can ping the WAN interface on that device. All right, so here's a question. Before we keep going. So, from PCA, I've been able to ping the default gateway, which is the interface here, and the loopback interface. So the reason why I can ping is because the router is directly connected to this network, and this network. So it can route the packets for this LAN network because it's directly connected to it. Tell me why I can't directly, tell me why the pings are unsuccessful going to 10.1.1.1 if it's directly connected. Anybody in the chat know why? And I'm going to catch up with y'all. See what's good. Clock rate. No cable attached. Down means no physical connection. Layer 1. Greetings from Holland. What's up, Master 25? Shout out to Holland. No phone. Can you say why you configure the loopback? Okay, hey, no phone. I'm going to tell you why I configure the loopback in a minute. Let me see why, if anybody answered this. Alright, so Larry's answer, I'm going to get back to you, no phone. I ain't forgot about you. So Larry's answer on why I can't ping 10.1.1, even though it's directly connected to router 1. His answer was you have to create a static route or use a routing protocol. Not the right answer, but I can see why you would think that. But you have to understand, this interface, 10.1.1.1, is directly connected to router 1. What about Richard Works? He says, Robbie, no, the router protocols, routing needed, different network. Okay, those are all great answers, but understand, remember when we were just talking about the interface on that WAN connection is down. So it's not going to be in the routing table. So if we go back and we log into that device, let me see which one is show host. So if we were to log into router 1 with telnet 71. All right, so we were looking at show IP route. Show IP route shows you the routing table in the router. So we go back to router 1. That network is not in the routing table. And the reason why it's not in the routing table, even though it's directly connected, if I can put the right command in, is because we talked about this last time, it's down, down. Anytime a interface on a router is shut down, it's not going to be in the routing table. Even though it's directly connected, it's not going to be in the routing table. Now, if we were to config T, and let's do this. We know we need to get to 2.2.2. I want to show you something. IP route 2.2.2, 255, 2.255, and then 10.1.1.2. Now, we just verified that, hold up. We just verified that when we did a show IP route before, that the 10.1.1 network was not in the routing table. It's not in there at all because the interface is down, down. I just did a static route pointing to 2.2.2 going through router 2. Do you think it would be in the routing table? Do you think this static route that we just configured will be in the routing table? Whose answers? Oh, my bad, Witcher works. Yeah, I need somebody to be a moderator. Hey, Daryl, handle the moderation, bro. Anybody else want to be a moderator, let me know. So Larry's saying that he thinks this static route will be in the routing table. Anybody else? Man, I miss you put on just tuned in. Hey, appreciate you turning on, Lapu. Yeah, it'll be in the routing table. Static route will not be in there. All right, so let's do a show IP route and see if it's in there. It's not in there. So what does that mean? So we know if we do a show run pipe include static, my bad, show run pipe include route. It's configured. It's not there. So this connection to this network is down, down. So even if you have a static route configured, even if you're directly connected, if you don't have a connection to that interface or on that interface, if that interface is down, either shut down or down, down, it's not going to show up in the routing table. So the reason why PCA could not ping the 10.1.1, even though it's directly connected, is because that interface is shut down. So if you're troubleshooting in a network, if you're like, okay, I can get to my default gateway, I can get to this network, I can get to these networks, and they're all directly connected, but when you go outside to the WAN, you can't connect, so you need to log into that router and start looking at interfaces and see if anything's shut down, anything is up, down, and start troubleshooting that WAN connectivity. And so that's our issue. There's an issue with the WAN connectivity from R1 to R2. It's shut down. And that's the reason why we have internal communication, but no external communication. That's basic troubleshooting as a network engineer. And we just went through that. We went through verifying why a route isn't in the routing table. One of the ways that a route that isn't in the routing table, we verified what up down means and what down means, and what else did we and we also configure some interfaces and a static route. So I'm gonna take a pause here, catch up with y'all before we continue on, and we'll go from there. Let me get Note Phone's question. So Note Phone had a question. He says, can you, before I get to the chat, Note Phone's question was, can you say why you configured the loopback? All right. Here's why I configured the loopback. Let's say you're a network engineer, right? You're on this network with PCA. Now, if I'm on this network and I need to communicate with R1 or R2 or R3, But let's start with R1. If I need to communicate with R1, and let's say I set up an access list to say I can log into the WAN interface through SSH, or anything coming from, let's say, I'm trying to give you a better example, because let's say PCB. PCB is a better example about logging into R1. Let's say I'm on PCB and I need to connect to R1. Now, if I need to log in from here or here, I could either log in by default. If I turn on SSH, I can use any interface that's configured on this router that has an IP address and is up. So I can log into 10.1.1, I can log into 1.1.1, or I can log into 192.168.1.0. But you don't want that. You want to kind of lock down your network to say, oh, okay, you can only log in if you're, let's say, coming from, so you would do a standard access list pretty much to say coming from this subnet source address can log into this. But let's say I have all these up, right? And let's say the only one that you can, I say this source and this destination. Well, if this network goes down, I won't be able to log into this device from PCB. If this network goes down and I'm attempting to log into this router using the 192.168.1.1. So that's bad. If this network goes down, and again, if you lose layer 1 communication, these interfaces go down, so I can't communicate with R1. So in order to always have communication with R1, a loopback never goes down unless you manually shut it down. So whenever you configure a loopback, it's for a couple purposes. For one, for you to be able to communicate to a device, whether it be, let's say, BGP or SSH or some type of management communication, because you know this interface, no matter what happens to any of these interfaces, won't go down. So as a router, you usually have, let's say, more than one. If you're dual home or multi-home or whatever, you're going to have more than one route to this loopback interface in order to always be able to communicate with this R1. So that's the reason for configuring a loopback, to be able to always have access to this network, to this device. I hope I explained that well. Anybody else got input on that? All right, so let me get to this chat and take a quick pause. If anybody's new to the chat and they're wondering where they can find this diagram that I'm using, hop on my Twitter. It's labeveryday. Twitter at labeveryday. I posted a link to it. Actually, let me refresh, because I deleted that one and I posted a new one with the correct information. So check it out. You can download it from there. All right, so let me get here. Battery side, I got you. Static route not being there. Cool. First of all, interface status. Hey, what's your words? He said, do you have a good point of contact? Are you looking for my point of contact? What you looking for, family? He said, Larry, now I get what you're saying. The interface is down, which tells me there's a layer 1 issue. Without layer 1, you can't establish a route. Facts. There you go, family. Correct. Loopback is for testing. Yeah, it's for testing, and it can be used for routing. Do GRE tunnel link afterwards. Yeah, I'm going to have to do that another day, because I want to make sure I get through everything on this lab, and then maybe next week we can do a GRE with a GRE tunnel and DMVPN or something. I should say it's Ali. That's way ahead. Hey, thanks, which works. Get shifty. Loopback stay up unless you manually shut it down. Facts. All right, cool. Loopback interesting. IP. Yep. More like a backup. Thanks, bro. Hey, no problem, family. Hey, Daryl. Then you do a video with Dewan. Hey, Daryl needs to do a video. We need to get him on. Hey, Daryl, we need to get you on, bro. Let's make it happen. Doesn't mean. All right. Before we continue, let me know where y'all from in the chat. If y'all liking it with this live stream, if you feel like you're learning something and I'm helping you out, let me know in the chat. Shout out your area code. Shout out your country code. Let me know where you're from. Get this video a like. Share it out. All that good stuff. We're about to continue on configuring the rest of these devices. All right, so we might 405 3474. Hey man, that is your zip code. I said area code, Larry. Dennis, yo, Mr. Bates. Hey, hold up, y'all. Y'all looking at a dual CIE in the chat. Everybody say what up to Mr. Bates. He's a great friend and mentor. All right, man. Shout out to Mr. Bates. Everybody say what's up to Mr. Bates. System engineer from Cleveland. Cleveland in the building. 216 in the building. I see you. Let's see. 352 in the building. Yeah, I've never heard of Ocala, Florida in my life. Where is that? Canada, what's good? 973. Jersey in the building. 405. 352. Tyler from the 330. Canton in the building. That's the hometown. In the building. Would like to see more live streams like this. Good job, Dewan. Thanks, fam. Every Saturday, 6 a.m., this is what I do. I live up technology. We talk about it. We troubleshoot. And it's just going to get more complicated. So you better catch it now if you're working on your CCNA, because eventually we're going to be on that CCIE by the end of the summer. It's DMV in the building, 407-860. Mr. Bates. This man dropped the zip code right. 202, the DMV in the building. Shout out to the DMV. All right, cool. All right, so back to the lab. So far we configured the network connectivity to PCA, and we verified that connectivity to R1. Now we need to configure R2, so we're going to go back into my terminal server. Disconnect from there, and let me do a show host so I can verify my connection to R2. So we're going to telnet to R2 using 192.168.133.1. My bad. And then the port number of that device, and the one, and my password, and we should be in R2. So R2, going to enable mode. Quick understanding of what just happened. So when I logged in through Telnet, I don't think I explained this previously. If you see this greater than sign, you're in user exec mode. You have limited privileges in the user exec mode. What you want to be in is privilege exec mode. If you see the pound sign, that's privilege exec mode. This is user exec mode. Here, you can do everything pretty much. If you have level 15 access, which is the highest level of access you can have on a Cisco device. So when you do when you configure your username for in privilege level 15, but you can do lower privilege levels, which limit the access that a person has. Normally, when you configure in a CCNA material, they tell you username, and then the name of the user, and then password, and that's a basic password. But when you do that privilege exec mode, the more you get into it, try different levels and see what happens and see what access you actually have. You can actually limit that, and you can control different views that a user has as well on a Cisco device. But we're just going to keep it basic. Anyway, show IP interface brief, and we're going to verify that there's no configurations on this device. We do that by show IP interface brief, and then we can do a show run. I already named the device R2, otherwise it would be host name as we know. There's no service password encryption, meaning there's no password encryption. So if I was to create a password, it would be clear text. Everything would be clear as text from the enable password to the console and the VTY passwords. No IP addresses, no access lists on the interfaces, no routing setup, and there's no configurations on the console lines. So the first thing we want to do is configure that loopback interface. And you remember why we're doing that. Just so we can always have connectivity, testing, management, access to this device, because that interface is always up. And as you can see, as soon as I do interface loopback, hold up. Yeah, them logging messages, yo. We gonna box in here. We're gonna box for real. I'm telling you, this is like the the most annoying thing ever is those login messages, but they're so valuable. They're so valuable at the same time. It's like a love-hate relationship with them login messages. All right, so as soon as you configure your loopback, it's gonna be up. But pay attention. We're gonna do something real quick. Wait a minute. I got you. So we're going here, config T. We'll configure an IP address on this loopback, and it's gonna be 2.2.2 since this is R2. And of course, you type the word IP address first. 2.2.2 and 255.255.255.255, meaning it's a /32. It is the only IP address in that network. So it's the network ID, it's the host ID, and it's the broadcast ID. All of the above. All right, so show IP interface brief. It's configured. Now we need to figure out which connection is connected to R1, and I think it would be, let me get my cables off. Alright, so that's, the top one is 1. So 0/0, and I think it's, if we do a show interface, serial 0/0. Remember I talked about last time, if you're trying to figure out what type of card this is, because I have a T1 in here as well, and I don't want to use the T1. So remember we said serial. But in this card slot, so these actually represent the slot number of your device. So this is slot 0 and this is slot 1. I should have said that last time. I don't know why I didn't. But this is slot 0, so when you plug into your Cisco device, above each card slot, it'll have a number. And so the way this reads, I forget what that is. I'm going to have to Google that. I forget what that is. I forget. And I hate that I forget. But there's a reason why I forget, but I'm forgetting. But it's cool. We'll get back to it. I'll make sure in the next live stream we Google it. But right here is going to be a slot number. So this is slot 0, this is slot 1. And this is serial. Matter of fact, I don't need to Google it. If anybody in the chat know what that first line means, let me know in the chat, and I'll catch back up with y'all in a minute. All right, so if we were to look at, if we change this slot number, you'll see that this is the T1 connection. Boom. All right, so we're using interface 0/0. So serial interface, the first. And then we'll put a description, and we'll call this connection R1. R1. And you'll see how important this will be once we really start getting into this lab. So I'm going to assign, you know what? I'm just going to do a no shut. So I brung up interface 0/0, right? I brung it up. What you think will happen now that I just brung it up? Is it going to be up? Is it going to be up, down? What do you think? So it's up. No IP address assigned. We need to assign that IP address. So show CDP neighbors. Verify we're connected to R1. So that's cool. So that is the right connection. And now let's do interface 0/0. And let's give it an IP address. 10.1.1.2.255. And let's do, I'm like, yo, can I type? And let's do a shut. Let's shut that down. Let's do a clock rate. And the reason why I'm doing the clock rate, I believe, you know what? I need to do clock rate on the other one. And we can tell that by show interface. Since it's a serial, I think you can look at the clock. You can tell if it's the DCE or DTE show controller, and let's go serial, and let's go 0. And anything else? /0. Serial 0 /0. Oh, I gotta do that one /0. Alright, so I bet you didn't know that, huh? I bet you didn't know that. When you're using serial connections, if you do the show controllers and then the name of the interface, so show controllers, we're using serial 0/0, it's going to tell you which side is your DTE and which side is your DCE. Understand that your DCE controls the clocking of that, the clock rate of that link between the two devices. So on the other side, I'll do the clock rate, but it's going to have the default clock rate by default. So I shouldn't have to set it, but we'll see if I had to. But I shouldn't have to. Older devices, you have to. Like my 2600 routers, I had to. These, I don't think so, but we'll see. Show IP interface brief. And it's shut down because I shut it down. So let's go back in here and bring it up, and we should have connectivity. So configure interface serial /0, and let's do a no shut. Bring it up. Show IP interface brief. Give it time to think. Boom. You see the severity levels right here. So this is severity level 3. Lets you know that the state of the interface has changed. And then severity level 5 lets you know that the line protocol has changed as well. So remember this, whenever you see these logging messages, so if we do a show log, before we keep going, I want you to get used to looking at these logging messages, these severity levels. Whenever you see those logging messages, I forget this device. I think for some reason it doesn't log to the buffer. It's supposed to. I'm not sure why it's not doing it. It was doing that last week. Anyway, if you were to take this right here and Google it. So if we pull up Google and I type this in here, you're going to see a bunch of Cisco documentation on what that logging message, that syslog message actually means. So if you're troubleshooting a WAN link, let's say you're remotely troubleshooting a WAN link, when you're SSH or Telnet in, you're not going to see those logging messages. They're not going to come up unless you're logged in the console. So if you're remotely troubleshooting a device and it's having connectivity issues, the first thing I usually do is this command right here, terminal monitor. And what that does is it turns on logging. Now, if the machine is blowing up and or the logs is ACL logs and all this stuff is coming to the device, you're going to see that, and it may just be crazy. And it may just not be, you may not be able to type. So whenever you do this command, it's only for that session. So if you were just to close that session and recreate this session, those messages won't be there. But the reason why I do that command is so I can see those logging messages here to see, all right, immediately if something's going on with a device. So like I said, if I don't know what this logging message is, I hop on Google, I Google it, look up Cisco documentation. You'll have blogs, you'll have community, you'll have basically anywhere you can think of, Expert Exchange, all the different helpful sites will pretty much tell you if it's a common issue where people talk about what that issue means. But Cisco will definitely have some type of documentation online that will tell you what that severity level means, because they're the ones that create the logging messages. So they'll have some type of, it may not be as descriptive as you want it to be, but it'll be at least some type of logging message to give you a start on what to do to fix the issue. So that's that. Now we have this up. Let's go to show IP interface brief. We have connectivity. Let's see if we can ping R1. Because remember, I mentioned about the clocking, so we want to make sure that we have connectivity. So we're going to ping the WAN interface to see if we have access here. Boom, we do. So we have connection from R2 to this outside interface on R1. Let's see if we can ping the loopback. Nope. We can't ping the loopback. And the reason why we can't ping the loopback is what? Let me know in the chat. I'm going to take a pause, catch up with y'all, and see why we can't ping that loopback. Anybody, if you've been watching, you will know. Let me know in the chat. I'm going to get back up here to these messages. Man, y'all been popping. It's been going down in the chat. I'm trying to get back up to where I was at. It's been going down. Hey, Daryl, I appreciate you holding it down, family. Hey, shout out to Devin Clemens for passing his CSIN on Thursday. All your fault. I'm going to get everyone together. Y'all been having this effect on start a class action. Hey, fam, I want to see you winning. I'm glad you're out here doing your thing. Keep winning, family. Keep going. Don't let nothing stop you. I don't care how hard it get. I don't care how many people hating. I don't care what you go through. If it is a roadblock, do what you can to get through it. Pray about it. Ask for help. Get a mentor. Whatever you need to do. Keep pushing. If you don't have enough time, if you got a family, it's hard to juggle. Study 5 minutes a day while you're in your car. Set a YouTube video up or get a podcast or something. Whatever you have to do to get to where you want to be, get to it. Don't let nothing stop you. Watch it. He says, hit me up. Route is a doozy. Hey man, route for me was cool. I couldn't freestyle that test. Drop your email. I'll share my Google Drive with you. Privilege 15. Yeah, this is crazy. I know someone 19. Yeah, he said he knows somebody that's 19 with 5 CCIEs. That's crazy. Yo, how do you even do that? You can't even take this CCIE until you're 18, I think. That's crazy. What program is he using? All right. Hello, everyone. What's up, Savage Scientists? What's good, family? Daryl Mitchell, what's popping? Sorry if I missed it. But what emulator is the one? Secure CRT. It's a link in the description on how you use it and how I got it set up. Check it out. Good morning, Gustavo. What's popping? Cool Shell. What are you using? Secure CRT. Savage Sciences. I thought he was running on real hardware from the thumbnail. I am running on real hardware. This is, look, bro. It ain't no game. It ain't no game. This is my real lab. Show inventory. This is my real lab. This is 1841. I got 3 1841s, a 3750, and a 2960 on deck. And then I'm also using, no, that's all I'm using in this lab. But I'm also using a 2800 series console device. Let me get on here and see if y'all results on why I couldn't ping 1.1.1. All right, the router does not know the route. Get shifted, shiftly? Hey, how do you say that? Shift, what? Get shiftly? Where are you from? What does that mean? Shout out to you, family. The router does not know the route where to get back. Interesting. Interesting. See? Interesting. I was going to say you were right. But, watch this. I debug IP packet. I'm going to show you something. Don't do this in production. Do not, look, I repeat, I am not responsible for it. Do not ever do this in production. Never. No. Look, I repeat, disclaimer. Disclaimer. I'm putting this in the chat. Disclaimer. Don't. Matter of fact, we need all caps. I need you to know not to do this in man, look. Disclaimer. Don't do this in production. Don't. Alright, so debug IP packet. Let's try that ping again. So if I ping 1.1.1, I want you to see something. Check this out. this is actually telling you what's actually happening right now. Let me do a URL. Turn that off. All right. So the source address is 2.2.2, and the destination address is 1.1.1. It's unroutable. It has no idea where to go. Now, let me turn that back on. Let's do another debug IP packet, and let's ping it from our serial interface. So we're going to do source serial 0/0. And so you were right about the router not knowing the route, but you weren't correct about it doesn't have a route back. It's not even going out of, it's not even making it to go out of the interface it's supposed to. Now, if I had a, let's say I do a static route, IP route, and let's go 1.1.1, and let's go 255.255.255, and let's give it the IP address of router 1. So now I put a static route from R2 going to R1 for that 1.1.1 network. Do you think, I got 2 questions. No, you know what? I got 1 question. Will this route be in the routing table? Let me check the chat. What y'all think? Only doing the production, that's your last day of work. Now, okay, Larry saying it doesn't have a way back. Get Swifty says yes. Hey, you know what? Hey, Get Swifty, I'm gonna call you Get Swift. I don't know, until you tell me what Get Swifty means, I can't say Swifty ever again. Get Swift. What's up, family? I said, yeah, okay. But not in the routing table. He says, okay, this saying is not it. Let's see. Let's go do a show IP route. Let's take a look. Show IP route. It's in the router table as a static route. And the reason why it's in the router table is because if we do a show IP interface brief, that connection is up. Oh man, what? All right, so that connection is up. And so if we do another show IP route, it's in the router table. But let's see if it pings. I'm gonna tell you now, it's gonna ping. And I'm gonna tell you now it's gonna ping. So let's ping it regular. But what do you think? Do you think it'll ping? Yes or no? What y'all think? I'm gonna take a pause. I'm gonna drink my peppermint tea. Keep the brain sharp. Boy, I like your channel. Boy, I rocks with you too, James. What's good, family? Yo, I don't know who you are, fam, but he said yes, or she said yes. Larry said no. Rick and Morty. You should check it out. Rick and Morty is an old show. Yo, pause. What's Rick and Morty? Rick and Morty. Is it Ricky and Morty or Rick and Morty? Rick and Morty. Yeah, I hope this ain't porn. Rick and Morty. Okay. I've seen this show, and I think my kids watch it. I just never sat down and watched it. Now, I'm going to check that. I'm going to get Swifty. Get Swifty. Let me see that. That's actually a thing. It's actually a thing. Yo, where have I been on? Yo, shout out to you, fam. You just put me on to something. I'm going to look that up. All right. So the question was, will it ping? We got a bunch of yeses. All right, so let's see if it pings. It pings. Let's do a debug. Oh, man. See, this is why you don't do this in production. Because when you do that debug IP packet, you're going to see all the packets going through a router, and it's just going to bar this down. This isn't per session. When you turn this on, this is on the device. So this debug will be on for everybody. Even if you close out the session, it's still bogging down that router, and that CPU is going to go like this, and the router going to you're going to have to unplug that thing because you're not going to be able to do the UR. Yeah, do not do this in production. I'll say that again. Now, if we read this from the source, which is my exit interface, to the destination of 1.1.1, let's see if we can get all this in here. I'm going to get all this in here for y'all. Yo. And it's routed through fib. So, a source, 1.1.1 to destination. All right, so this is telling you that it's being routed. If we look at this, I'm trying to make sure y'all can see all this because it's kind of hard to see all of it. But if you look at this right here in the routing table, it's saying from my WAN interface, I want to reach this network, and I'm going out of this interface. This is where I'm actually going because it's going through fib. It's telling me which interface it actually exited out of my device. And then it says sending. It sends it. And then it says received it from 1.1.1 of the source of where I sent it. And then the destination is me, my WAN interface. And that's basically the flow of everything. That's it. That's it right there. That's it. So let's see what happens when we try to ping PCA. You think that'll work? Let's see. So let's try to ping PCA at 192.168.1.2. See? Again, the source is 2.2.2. And it's like, yo, I have no idea what you're trying to do, family. So let's source it from our serial interface. See what happens. Still, it's like, yo, the source is the WAN interface rather than the loopback. And it's still, nope. And actually, let's do a show IP Ceph. Let's look at Ceph. And then let's actually look at the IP address to see what Ceph says about. It's like, yo, I ain't got no route adjacency for that. I don't have an exit interface for that. I have no idea what to do with that. But if we was to do the same thing for 1.1.1, it's going to tell you something different. It's going to be like, yo, I know how to get there. This is my next hop. This is how I'm going to get to that route. Boom. And that's basically how the fib and the Ceph works when you're actually troubleshooting a device. Sometimes you'll see something in the routing table and you're like, yo, this is the next hop. Remember I mentioned that loopback. The next hop may be a loopback address. And when you look at Ceph, it actually tell you which interface that packet is actually exiting your device. Because sometimes you'll think it's actually going out of one interface, but it's not. So you actually have to look into Ceph to see actually what's being routed. How are my packets actually moving? How are my packets exiting my router? I need to know immediately. I cannot wait for this. I need this information right now. All right. So what we need to do is two things. We need to configure a static route, show IP route. We need to configure a static route on this device on our tool to PCA. So let's go in here, config T IP route, and let's do a 192.168.1.0. So it's a /24. So this is a static route. So we want that whole network. Anything /24, you need to take this interface. Now I don't want to talk about that right now. That'd be a little complicated. So we'll just keep it simple. So I want this to be my next hop. I want this IP address to be the next hop. So, and I could talk about that now, but we're going to get deep in the weeds if I start talking about recursive routing. I'm not going to talk about recursive routing. I'm not going to do it. I'm not. All right, so show IP route. We should have a route in the routing table. And we should ping. Let's see if we can ping 192.168.1.1. We can ping. Let's see if we can ping .2. Yo. See, you all rude. You all rude interrupting my live stream. Come on, family. All right, cool. Let's see if we .2. So we have network connectivity because, and I'll show you why we have network connectivity here. before I do, let me source this from 0/0. Yep, we good. So we have network connectivity. Let's get out of here. Let's do a Control-Shift-C, and let's do a show host. And we want to go into router 1. So let's do a telnet, and let's go into router 1. Connection refused because I have to actually disconnect. And let's do a show session to see where I'm actually logged in. And then I'll have to disconnect session. Let's disconnect 1. Yep. And let's try to reconnect that session. Telnet and 71. 1 Cisco. And we should be in R1. Alright, so if you look at the routing table for R1, R1 knows how to get to R2 because it's directly connected, and it knows how to get to this the internet basically because we have a static route. Which, can anybody tell me the administrative distance of a do I want to do a directly connected route or a static route? You know what? What has a lower administrative distance? A directly connected route or a static route? Let me know in the chat. Let me know in the chat. Let me know, Dewan. Can run a S command. It would probably say access to a device. Hey, yeah. Hold up. I will talk about that too. He was in network since he was 8. He was in network. Okay, so he got 5 CCIEs because he was in network since he was 8. Or that's what David's saying. Okay, directly connected. All right, so let's look at show IP route, and let's look at one of these directly connected routes. So let's do 10.1.0. The distance is 0. Let's look at the static route. Show IP route 2.2.2, and the distance is 1. Directly connected wins. Hey, you win a, I don't have nothing to give you, but a round of applause. Shout out to everybody that did directly connected. And again, show IP route, you look at the route, it'll let you know the administrative distance, the metric for that route, if you got any route descriptors, and it'll let you know where it's learning it from pretty much. This is a static route, so it's not going to say anything. So that's pretty much how you doing that, family. What's good? Brownie points for all of you that said directly. I'm a Grocky. What's up in the building? What's up, family? Happy Saturday. Around the bows. Hey. So cool. So we have connectivity from everything on R2 to PCA, and then PCA to R2. Now we need to do the same thing for PC3. Let's get that up. Let's get that configured, and then we can be up out of here. Verify connectivity, and then we should be good. Alright, so we need to go back to R2. I think it's, nope. Man, I gotta disconnect them sessions. Disconnect 1, confirm. Disconnect 2, confirm. Let's go back to, let's do a show host. I need to just set up telnet on these devices, so I can just hop through them like that. That'd be easier. So we're going back to R2. So we're going to go 192.168.31.273. All right, cool. And we're logging in Cisco. All right, so we do a show IP route. Cool. So we have 2 static routes. We have a static route to loopback 0 on R1, which is 1.1.1.1, and then PCA's network, or the 192.168.1.0 network. We have static routes for both of those so we can get there, and they have administrative distance as 1. That's something we learned. Now, the next thing we have to do, let's verify interface description. Just to verify, so we need to go into serial 0/0/1 and configure that connection to R3. So let's go do that. And let's go interface serial 0. Man, I can't type, bro. And let's give it a description because we need to know what we connected to. We need to know. We don't need to play no games. We don't need to do no CDP. We're going to go ahead and get this right from the jump because CDP is probably disabled on your WAN interface anyway. So, all right, so IP address, and then where you need to do, let's verify that subnet. So this is going to be .6. I made it .6 because we want R2s. All the connections on R2 will be even. And then all the connection to, let's say, our spokes is going to be odd. All the connections on R2, which is the hub, let's call it a hub, and which is ISP connection, they'll be even. And then all the connections on the spokes or the site routers, the client routers, they will be odd. You want consistency in your IP address scheme. Think long term. Don't think short term, family. Like, what's going to happen 10 years from now? Or that's a long time. Not 10 years. Let's say what's going to happen 2 years from now when somebody else comes in and you're no longer there. Because nobody's really staying in IT companies like that. And let's say you stay longer. Let's say 3 to 4 years. And another engineer comes in, and then what? You know what I mean? So you want to make sure you keep that documentation on point. And plus, let's say you get promoted. You know, you want to mentor some young network engineers. So you got to think long term and look out for other people. Look out for your teammates. So documentation. Document your ports and document your tickets and document for yourself. You know what I mean? All right. So again, we talked about this before. The interface on R3 is down, so there's no layer 1 connectivity to R3 from R2. So even though I configured an IP address on this device, let's do a show IP interface brief. And we only want to see the configured one, so we'll exclude any unassigned IP addresses. Clean show IP interface brief. We're going to exclude all interfaces that have no configuration. So now we only see our 3 connections on this R2. And what you can see is down. Remember, this is layer 2 and this is layer 1. So if it's down here, you're definitely not going to have layer 2. And if it's up here, you can still be down here. So right now, we know we don't have a physical connection either on our end or their end. The cable's not plugged in or the interface isn't up. Something's blocking that physical connectivity on that interface. So we have this configured. It's good to go. We got a description on it. And let's go ahead. No, because somebody just may be tuning in late to the live stream. So we're going to give them a chance to answer the connectivity questions. So let's get out of here. Matter of fact, let's save it. Let's save it before we're out, just in case anything happens. Remember, copy running configuration to the starter configuration. So right now, what we just configured, running configuration. If we reload the device, if we don't save it, the starter configuration is going to load, and it's going to look like it's straight out the box. So we save it. Boom. Now we can exit this device, leave it running, whatever we want to do. You know what? Before we switch over, how do you verify? I'm going to ask a question before we switch to R3. I'm going to ask a question. I want y'all to answer in the chat. How do you verify the uptime on the router? I already told you the answer, but if you've been paying attention, you'll know it. But if you already know it, put it in the chat. If you don't know it, still put it in the chat. Let me hear it. How you verify the uptime on the router? Show version. Anybody else? Show version. Megan Neal, what's up? What's up, Almighty? Show version. Hey, man, y'all up on it. Show version. See your raps. Show version. All right, yeah, they're correct. So I mentioned this in the live stream last week. We see right now that this is down. And you're like, man, what happened? Like, why is this down? Or let's say you come in here and you see that it's admin down and it's supposed to be admin up, or it's supposed to be up. It's like, okay, what happened? Did something change? What you want to do is verify the uptime, because it could have been a power outage. Somebody could have unplugged the cable. And if you know it's supposed to have been up for X amount of weeks, you do a show version and it'll tell you how long that device is up. Boom. And it'll let you know. So show version, router 2 uptime has been 1 hour and 31 minutes. If you see 31 minutes or 21 seconds or something, you know this device has been either unplugged, there was a power outage, it's having a hardware issue, so it's constantly rebooting. That's basically how you're going to tell how long it's been up. So that's that. Now let's log into router 3, get that configured, and then we can be up out of here. Show host, telnet, router 3, 92.168.33.1, and we're going to 272. Username, password, and we're in R3. Verify the configuration on R3. Host name is already there because I have it configured, so I'll know which device I'm logging in every time I do this. So show IP interface brief. And all the ports are administratively down, and there's no IP address assigned on this device. That doesn't mean there's no configuration on that interface, but it lets you know that it's been admin shutdown, means you have to manually bring it up, and there's no IP address assigned, and it's not configured for DHCP. So what we need to do is do a show running configuration, verify a couple things that we can see from the basic running configuration. There's no AAA configured. There's no service password encryption configured. There is a host name configured. And there's no IP address configured. There's no domain name configured. There's no routing configured, because you will see that in the show run. There's no console password, no console configurations. There's no banner. There's all basic configurations, basically out the box. Basically. Now, if you want to verify that, you do a erase startup config and all, erase startup config and then reload it. But we don't need to do that. So what we need to do, this is the network diagram that we're using. Again, for anybody that's just tuning in, check out my Twitter. I put a link in the chat. I'll put a new one in the chat. You can download this diagram if you want to light this up for yourself and walk through this video. Basically, we're doing static routes. I want to do ACLs, but I need to chill with my family. I've been on here almost 2 hours. So next week we may use the same diagram and go over DHCP and ACLs, and maybe some NAT as well, depending on how much time we have. But we'll at least get to the static routing of this lab to get you configured. And once this lab is live, by Sunday I will have timestamps to when we go over everything, so that way when I'm talking like this, you can just skip over that. So, all right. Now, if we go back here, we're on R3. We verify there's no configuration. What we need to do is configure the WAN interface, the loopback interface, and the LAN network. So the WAN, LAN, loopback. WAN, LAN, loopback. LAN, WAN, loopback. Hey, y'all gonna make, hey. It go down. Cool. Let me get that A. How long has it been like that? Hopefully y'all can see, but it's aligned now. My bad. All right, so the first thing we're gonna do is configure our loopback. So interface, loopback, IP address, and this is gonna be 3. Yo, hey, console login messages. We're gonna box. I'm telling you, you don't want these hands. You don't want these hands, family. All right, so we're gonna get this. So those don't interrupt us while we're going through the flow of configuring our device. You don't want no interruptions. Yo, we need some lo-fi hip hop. Matter of fact, I'm about to share y'all what I listen to when I lab. Check this out, family. Check this out. Check this out. Lo-fi hip hop. Yo, this channel right here. Yo, we don't want to hear them ass. We don't want to hear them at all. Check this channel out. This is what I listen to when I lag. Either this or classical music. But this right here, hey, look. It's the right frequency. I get that. I get my peppermint tea. I turn the lights down low. Man, look. Hey. All right, so back to what we was doing. So we was configuring the loopback IP address 3.3.3.255. Oops. All right, so we talked about this earlier. If for those of you like, yo, why are you configuring the loopback interface? And so a bunch of people in the chat, they commented, they got it right, they understand it. Basically, the loopback interface is for management. When you need to access the device, this interface is always up. So if we do a show IP interface brief, the loopback interface is going to always be up unless you manually shut it down. So any type of communication, troubleshooting, BGP, management, you name it, the loopback is the IP address that's your guaranteed to, how can I say, to be up and to be able to troubleshoot if a device is up or down or if there's an issue. You know what I mean? But at the same time, it could be an issue on your end, not necessarily this router, but you know if you can't access the loopback, you can't access the WAN and the LAN on a router, you know that, okay, can I get to the internet? Can I get to here? You know, that's basic troubleshooting. But basically, if you need to communicate with a device and one of its interfaces go down, like if the LAN goes down or the WAN goes down, I can still get to this loopback. If I have multiple connections, like if I'm multi-home from this router, and like let's say I had a connection from R1 to R3 and from R2, so basically I got this triangle right here, right? If the connection from R3 to R2 goes down, I can still communicate with that loopback. Or if the connection from R1 to R3 goes down, I can still communicate with the loopback. You get what I'm saying? That's basically the purpose of the loopback. So we got that. I think that I beat that in your head enough. All right, so show IP interface brief. The next thing we need to get configured is our connection to R2. So again, how do we verify our connection to R2? Remember, I mentioned before. So if you do a show interface and then the interface, I have a T1 card in here and I have a HWIC card in here. So if you go in here, this says serial. If I do a show inventory, that'll let me know the cards that I have installed on my device. And I mentioned before that I have a HWIC and I have a T1. Those are the two cards that I have. Now, I thought this showed you the slot, but it doesn't show you the slot that they're in. But basically, if I need to know the slot that it's in, if you look at the router, there's a way to do it from here. And I can't remember how to do it. And that's, let me see something. Might be like show slot. Nope. Show controllers. Show controller. Before I move on, controllers, serial, let's go with 0/0. Let's see if this tells you the slot that it's in. So it lets me know that this is the DTE, meaning that R2 is doing the clocking. I thought this doesn't even tell you the slot. Yeah, there's a way on here to tell the slot. You know, it might be in show inventory. If somebody knows, let me know in the chat. Oh man, come on, family. Oh man. All right, so let's do a show version real quick. It might be in show version at the bottom. That might not even tell me either. Show platform. Let's try show platform. Yo, you about to have me scrolling. Nope. Oh, duh. It's the name. Dang. Hey, brain, let me drink some peppermint tea. We just talked about that. It's the name. Duh. All right, yo. So if you look at the router, you can tell the slot number. So this right here is the slot number. This is the slot number. This is the slot number. So if we do a show interface that we talked about before, show interface, it'll let you know that, okay, in slot 0, your serial HWIC is installed in slot 0. Now, if you were to do a show interface 1/0, it'll let you know that your T1 is installed in 1/0. I just had a brain fart. Duh. Dang. Yeah, I'm telling you, yo, I don't know everything and I don't even try to know everything. See, that's why I need to live with y'all. I'm glad y'all are here today. Thank you for rocking with me. If you enjoying this live stream, hit me with a like. And if you also enjoying this live stream even more than just hitting it a like, let me know in the chat. Show your boy some love. All right, so the next thing we want to do is configure 0/0, 0/0/0 connection to R2. Let's configure that. So interface and description, connection, R2. Boom, got that. And we need to configure the IP address, which is, remember, on the LAN, all the spokes is going to be even. This is a 10.1.1.4/30. So the IP address is going to be 1.5 and a 252. Boom. And we'll do a no shut. And we should have network connectivity to R2. And cool. So we do a show IP route. Let's look at our routing table. These are our directly connected routes. And for brevity, we have our directly connected loopback and we have our directly connected interface here. But let's go also, let's configure our LAN connection and let's go IP add. Yeah, that will work. Let's do show IP interface brief, and my connectivity to from R3 is in fast Ethernet 0/1 description, and let's call this connection PCB. Boom. And then let's go IP address, and that's going to be 192.168.2.1, and then /24, and we'll go a no shut. Now, so what I have over here for you guys and girls is a virtual. Let's resume this virtual machine. Virtual machine is starting up. And so we'll log into this virtual machine. Hold up. Cool. Yeah, I ain't used this virtual machine in like, I don't even know when. It still got my, alright, so when you're on a virtual machine, one of the things that you can do is Windows R. Windows R, that brings up your run, and if you type CMD, that brings up what you call the command prompt. Command prompt is your friend, it is your friend. And if I do a IP config, this will show me that I have no IP address configured. If I do an IP config all, this will tell me all my DNS information, my default gateway information, my NIC information, my MAC address information, my DNS information, and all that good stuff. So what we need to do is go in here and configure a IP address manually. So we'll go down here to Windows, type network. If I can type network, the word network, and this should bring up this network status, which I got to go through all this to actually get this working, but it's all good. Adapter options. Yo, come on, family. Let's go. Don't do it. All right, cool. Got that. And we're going to manually configure an IP address. That IP address is going to be 192.168.2. And the IP address and default gateway. Okay, before I keep going, let's do this. Let's do this. Because you need to understand basic troubleshooting. This is beyond router and switch troubleshooting. You need to understand how to actually troubleshoot from a user standpoint. So we're going to start here. So now that I have my IP address configured, let's see if I can ping my default gateway. Thank you, Tyler, for that love. My default gateway is 2.1. Hold up, y'all. I might need to do something. Actually, let me do it. I'm gonna go around because I need to do a workaround on this one. So let me go back. Let me do a IP config, and let's do a release. All right, let's go back to, because this is going to be a little different than the other one. So let's go here. Let's do IP. Y'all getting a bonus right now. DHCP excluded address 192.168.2.1. 192.168. No, we just need to exclude that one. So, boom. And let's just do an IP DHCP pool for this device. Since it's a virtual, I need to assign my actual NIC on this device IP address. So we'll call this Lab Everyday pool. Shout out to Lab Everyday. Let me get that Lab Everyday in the chat. So default gate router 192.168.2.1. And then the network that we need is going to be 192.168.2.0/24. And we should start assigning IP addresses. If I do a show IP DHCP bindings, we should start seeing some activity here in a moment. I may have to log into my switch in order for this. You know what? We have a layer 1 issue, people. We have a layer 1 issue. See? So, I determined this because if I do a show IP interface brief, right? And I'll tell you. So, if I do a show IP interface brief, I'm actually up. Like, I'm up because I'm connected to a switch. But the reason why this wouldn't ping, general transmit failure, meaning like, yo, what are you talking? Ping who? I don't even, what are you talking about? So I got a layer 1 issue. I got to plug this in real quick. Shout out to the Lab Everyday squad. I'm going to plug it into my switch. We should see some IP addresses start being handed out here real quick. They should start being handed out. So right now what we're experiencing is spinning tree. Spinning tree. And can anybody tell me how long basic spinning tree takes to go from never mind. We good. It's already up. So binding. Wonder if I gotta put it in the right VLAN. Don't play with me. Don't play. Don't play with me. Alright, so troubleshooting. So let's go show host. Let's see how this switch is configured real quick. So telnet 192.168.1 actually 33.1 and then 2070. Dwan and Cisco. Cool. Alright, so we're in this device, so let's do a show IP interface brief. See? Okay, so the issue is this switch is getting an IP address from something else. Oh, this switch is plugged in the R. You know what? Which one's plugged in the R3? So that's R1. This is R. Okay, so we're good there. This is not unplugged. Alright, so let's go in here. Let's get this IP address on VLAN 1 right. So we need to go to interface, VLAN 1. Let's do a shut on the VLAN 1. And let's do a no shut. And so, come on with the messages, family. Alright, so if I do a show IP interface brief, I should have a different IP address for this. Alright, so it came up. Come on. Alright, so as you can see, alright, let me show y'all this before we keep going. So in the previous lab that I did, let me just move this over. In the previous lab that I did, I only have VLAN 1 configured on the switch. So in the previous lab that I had an IP address issue to where it still had the old IP address from my lab, my previous lab, and I need to remove this IP address. Otherwise, this switch is not going to be able to communicate on VLAN 1 to be able to hand out IP addresses. So now it should be able to ping R3, so ping 192.168.2.1 on R3. Good. We have network connectivity there, so we're good there. So now if I go back to this PC and I do a show, I do an IP config, release. I think since I manually assigned it, I might have to get another one. So let's see if we do it. Nope. So let's make sure that we have network status, adapter options, and I need to make sure this port is in VLAN. So let's go to, this is a layer 3 switch, so I need to do a couple things. So no IP routing. If you have a layer 3 switch, you have to turn off routing. So we're going to do that. Then we're going to go into interface. What is that? Fast Ethernet 047. Let's look at the interface naming convention. Oh my goodness, here we go again. Fast Ethernet 10/47. Alright, and then we need to make sure it's a switch port since it's a, and then we need to make sure it's access. So switch port mode, access, and then let's do spanning tree, port fast, because I want this thing to go up super fast, and I'm going to do a shut, and then we'll do a no shut. And now let's see if this grabs an IP address. And it still says not connected. Well, spanning tree should have came back up. Let's make sure this is good. We don't want to use that. Close. Ethernet 0 should be. Why does it say not connected? Now, what does my NIC actually say? Yeah, I might not be able to do this because of the way my computer is configured right now. Because it's not even saying it's up. Because I changed the adapter. Yeah, I'm not going to be able to use the PC. Technical difficulties, I'm going to have to go back and reconfigure my PC. So, I'm not logged in the way I'm supposed to be to make this work. So, it's not going to work like that. So, what we'll do is we'll use the switch to simulate simulate this environment as well like we did on the last one. So IP interface. Yo, there go them login messages again. All right, so if we were to ping, so right now, I'm going to do 2 things. I'm going to pause, catch up with y'all, and then we're going to come back and verify we have connectivity from here all the way through and here all the way through, and that'll complete our lab. But the next one, I'm going to make sure I got this virtual set up right so we can get it done. Because right now, if I go into my NIC and try and configure my NIC on my PC, it's going to disconnect our connection. And I don't want that to happen, so we're just going to use what we got until next time. So, all right, so let me catch up in the chat, man. Yo, hey, Tyler, thanks for that super chat, man. I appreciate it. Showing some love from the Lab Everyday family. Thank you for the lesson, DeWine. Go Browns. Shout out to the Browns. Hey, y'all know we winning this. Hey, y'all know we winning this. I can't say the word, but you know we winning the big game, right? You know we winning that big game, right? All right, man, it's been a lot of communication in the chat. Let me check y'all out. What's up, Adrian? Been a minute, family. Lo-fi hip-hop is where it's at. Fact. Lo-fi is on point. Lo-fi is, yeah, that bass is serious. That lo-fi is what's up. DeWine, which terminal? Hey, thanks, Clyde. Appreciate that, family. James, what's up, fam? I'm on packet trace because, the packet trace, it works. So the DCE on the same suite, show controller, show platform. I think maybe somewhere in the show hardware, show chassis, show transceiver. Hey, I appreciate y'all coming through in the chat. Y'all really, that's what's up. No problem, bro. Like that. James, what's good, family? I put something about the lab on my hoodie. Hey, thanks, fam. I appreciate that. Barry Hampton, thank you for what you do, DeWine. Hey, much love, fam. LD, appreciate the work. Is this every week? Every week, 6 a.m., Saturday mornings, we will be in the lab. We will be deep diving. We will be talking technology. I'll be catching up, answering the questions that you have. I will be running into rabbit holes like I just did with my NIC or my virtual, all that stuff. No shame in my game. I'm here to learn just like y'all. Let's get it. George, what's poppin', fam? Thanks, big man. I thoroughly enjoyed this session, and we'll be with you next Saturday. Time for the young one, Jules. Hey, shout out to the young one, the 2-year-old. That's a fun age. Which it works. What's up? James, he said, Lab every day. I don't very appreciate what you do. Facts. PowerShell. Hey, it's Lab every day. I see y'all showing love. Lab every day. It's on Lab on this shoot. All right, every day help me better my skills and become nice. Facts. Double net. Big layer 1. Oof. Oof. Man, I'll do some things in the lab after returning. Around that way in a nutshell. Hey, what's up? Don't do that. Ha, don't say it. Make sure the VM is set up to use a virtual switch. Yeah, hey, you know what? Hey, which it works. I actually set it up with the virtual switch, and it is set up correctly. But like I said, the way I'm logged into my computer, if I try to do anything management-wise, it's going to disconnect this connection. So I don't want to mess that up and just drop that live stream. So shout out to y'all. Shout out to everybody. Let's get back to get this going. Let me see. How many people we done had on today? Let's see. Let me look. Man, we got 76 people. Yo, how many likes we got, man? What's up with the likes? If y'all enjoying this live stream, let me know in the chat, man. I appreciate everybody tuning in. And if y'all enjoying, y'all learning something, like I said, let me know in the chat. If y'all enjoying this live session, y'all want me to keep going, let me know in the chat. Show your boy some love. Thumbs up. Yo, Lab every day. This is what's up. Super chats, whatever you want to do, show your boy some love. All right, so back to the lab. So right now, what we're going to do, and I just changed this host name so y'all don't be confused. So what we're going to do is make the host name of this switch to be PCB. And so now this switch is acting like a PC. So what we're going to do is, it's not acting like a PC. It's acting like a, hey. No. Hey. Stop talking back. Nah. Trying to interrupt me again. See what happened. Yeah, that's what I thought. All right, so 192.168. default gateway. Can we ping it? So what I just tried to ping was from PCA to the default gateway on for PCA. I can't ping it. I'm getting all U's. All U's. Alright, so let's see. Let's see if we can ping the default gateway on router 3. 192.168.2.1. We can't. Can we ping this loopback address of 3.3.3? What y'all think? Let me know in the chat what y'all think. Cool. So we're going to try and ping the loopback on R3. Boom. We can. Why can we ping it? Because this interface is up and it's directly connected on router 3. Now we're going to try to ping this WAN interface on router 3. Think we can? Let's see. We can. It's directly connected and this interface is up. Now, let's see if we can ping disconnection on router 2. We're just going to keep going until we can't ping no more. We can't ping. Can anybody tell me why we can't ping this directly connected interface on router 2 from PCB? Let me know in the chat what y'all think. Why we can't ping from PCB to this directly connected interface on router 2. Let me know in the chat. Shout out to the mailing list. Woo, the mailing list. I'm sitting there reading and talking. Hey, shout out to the moderators, yo. Everybody that's been holding it down in the chat, people that's been interacting, people that's been helping out. Much love. I appreciate y'all. Need a routing protocol. So Charles F is saying that you need a routing protocol. Routing protocol. Which works. You need a route. Sunny saying VLAN not configured. Tiffany, what's up, family? Good to see you, Tiffany. Spinning Spiral 32. Lab every day. Big ups, the one from Birmingham, UK. Birmingham, UK. Hey, what's happening, fam? Shout out to you. Lapo is saying RIP version 2. Senor Rap says R2 needs a route back to PCB. Shout out to Senior Raps for the correct answer. Let's hop over to router 2 so we can check the facts. Because that's all we're talking is facts. We're not talking no ifs, ands, maybes, no buts. We talking all facts. So let's go over here to router 2. I got to disconnect this connection. So show session. Yo, man. Hey. I'm going to have to write a script or something to just go ahead and disconnect these immediately. Like, this is whack. Disconnect. Tripping. Alright, so now we need to, let's go back and do what I was doing before I was rudely interrupted. Alright, so now we're on router 2. And if we look at the routing table on router 2, hey, so if we look at the routing table on router 2, there's no route going to this network or this loopback. So although router 3 is directly connected to router 2, when we're not going to do it. I'm not going to do it. We'll do it the easy way. So if I do a show IPsec on the directly connected route to router 3, it knows that I have a valid adjacency and it's going to go out this interface. That's what a route, it's like, yo, this is where I'm going. If I do a show IP route on that route, it's like, yo, I'm in the routing table. We good. The metric is 0. I'm directly connected. It says connect. We good. I know how to get there. But if we do the same thing for 192.168.2.1. It's gonna be like, yo, I ain't got this in my routing table, fam. I don't know what to do with this route. And then the same thing for IPsec. 192.168.2.1. It's like, I don't even have a default route. If I did, that's how I would handle it, but I don't, so it ain't nothing I could do. There's no route adjacency, so it's nothing I can do with that. So what we need to do is go over here and configure a static route. That's what this whole lab has been about, is setting up our network, getting connectivity to everything. So we're going to say, okay, in order for me to get to 192.168.2.0, I need /2/24, I need to go to router 3. Boom. Now, if I do a show IP route, you can actually see, all right, I know how to get there. There's a static route in the router table. We good. That's how we get there. Now let's do a show. Let's try and ping. Before we do anything else, let's ping. 192.168.2. Let's try. We good. Let's try PCB. I think I know why this isn't happening. I think I know why, because, yeah, I set up DHCP. I didn't manually put that IP address in. Yeah, I set up DHCP, so it was the wrong IP address. That's why I didn't ping. So let's try it again. All right, ping. So we good. So now we do a show IPsec on that route. Well, actually, let's start with show IP route on that route. It's like, hey, I got a static route, homie. We good. This is my next hop. Hey, this is how I'm gonna get there, fam. Now if we do the same thing for the Ceph on that route, it's like, hey, we good. Recursive. We'll talk about that in another video, though. Another video. But so that's route. We got routes. We should be good. Now, let me make sure we got it. What I didn't put in here though, and I'll show you. So we're directly connected to router 3. We connected a route to PCB. Do you think from router 2 we'll be able to ping this 3.3.3 network? Let me know in the chat. Do y'all think I could ping the loopback of this device? Hey, what up, Erica? Oh, man, I'm still live. Yeah. I'm gonna get off in a minute. I'm trying to wrap up this lab. I'll call you right back. All right. Bye. All right. So we don't have a route in the router table to 3.3.3. Can we ping it? No. There's no router in the router table. We don't know how to get there. So let's configure a 3.3.3 and get that popping. So IP route 3.3.3 and 10.1.1.5. Boom. And now, boom, we can ping. So now let's check connectivity from PCA all the way through. Let's see if PCA can get to everything, and we'll wrap up this lab. I'll get to the chat, and we can get up out of here. So let's go over here. Let's do a show host. We need to go to telnet 192.168.269. That ain't gonna work. Alright, cool. So now what we're doing in our lab, and like I said, for those of you that may just be tuning in, This lab is on my Twitter. I put a link in there. Lab Everyday on Twitter. There's a link to this lab. You can download it, lab it up, go through this video, and learn how to set up static routes and troubleshoot, all that good stuff. So, now we need to verify from PCA all the way through. So we need to ping loopbacks 1.1.1, 2.2.2, and 3.3.3. And let me see if I remember how to do this. Let's see. Oh, no, I'm on the switch. I don't think a switch can do it. Nope, switch can't do it. So we'll ping 1.1.1. Boom. Go back and do the same thing. 2.2.2. 3.3.3. Uh-oh. 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 We don't have connectivity to 3.3.3. Can somebody tell me why we don't have connectivity to 3.3.3? So PCA can get to this loopback, but can't get to this loopback. Can anybody tell me why? Let me know in the chat. Yeah, I definitely wanted to go that tickle route. That would have been way easier, but we good. Hey, thanks, Daryl. Thanks for tuning in. Thanks for moderating and all that stuff, bro. I'm going to hit you up. Okay, Clyde, that's a great point. Tay, or Ty, Quan, that's a great point. No route. All right, so what doesn't have a route? Can you tell me what doesn't have a route? Charles, static route. Hey, thanks for tuning in, Daryl, man. I appreciate you, family. Yo. All right, so PCA is unable to ping loopback on R3. The reason why it can't ping this loopback on R3 is actually probably two reasons, but we'll fix the first reason. Hey, which it works? Holla at me. No route from R2. Quan saying no route from R2. But check this out. Let's go to router 1. Let's go to router 1 real quick. So we're going to get out of here and go to show host. And let's go telnet. Let's go to router 1. 3.1. 2071. All right, so we're in router 1. Let's check the router table of router 1. Show route. So if you look at router 1's routing table, it doesn't have a route to nothing on our router 3. It has no idea how to get to anything on router 3. So we actually need to configure a couple things. So let's go in here. We actually need to configure 3 networks. We need to configure a route to this network. We need to configure a route to this network. And we need to configure a route to this network on router 1. And then we'll see if we have connectivity. So let's go over here. Config T. And we can verify this just like we did before. Show IP route. And let's go 3.3.3. And there's no router in the routing table. So it's like, yo, I don't know how to get there. So let's go config T. And let's go IP route. And 3.3.3. 255.255. And then we'll tell it, all right, our next hop is router 2. And we need to do the same thing for the other LAN connection on router 2. So we'll say 10.1.1.4 network. And we need to do the same thing for the route to PCA. So 192.168.1. If I can type, and we're going to tell it who our next hop is. And that's going to be router 2. So we had to configure 3 networks. so to know how to get to PCA. But if we wanted to get to this loopback, this is what we needed. But if we want to get to these networks as well, this is what we needed. In order to get to PCB, we needed these static routes. So if we go to the routing table, y'all be rude, man. Them syslog messages be rude in the mud. Alright, so you can see all these routes are in the routing table. So 3.3.3, 10.1.1.4, and 192.168.2.0. And so if I do a show IP route, it'll like, yo, I know how to get there. So let's see if we can ping it from here. Can anybody tell me why I can't ping it? Anybody? Anybody in the chat? So somebody's saying let's go to the ISP. So let's check the ISP and see what routes it has. So show host again, and let's go telnet, and let's go 192.168.33.1, and then 273. Let's disconnect. Let's disconnect all these sessions. 1, 2, 3. This is 4th one. Alright, so cool. I should be able to log in now. Yep. And boom. So we're in router 2. Let's check his router table. So router 2 should pretty much know about everything. It has static routes for everything. 3.3.3, 2.2.2, 1.1.1. Both for the PCA and PCB. So the issue is on router 3. Although actually, you know what? We need to do this because we haven't done this yet. So we're going to have to do it. Show us. I'm going to show you something. So troubleshooting again. If you don't have access to routers and switches, basic troubleshooting. We're going to start here. So let's go to telnet and 192.168.33.1 and 2070.69. Go back into this device, which is PCA. So let's go trace route, and let's go to this 192.168.2.3. And let's see, actually, you know what? Dang it. Dang it. Alright. So let's see what happens. Cool. No route from router 2. Check the router table. What's good? Yes, we're in Canada. Shout out to Canada. Hey, where y'all from? Let me know in the chat. So, to this network, we get to our default gateway. Let's see where we go next. Oh. They're like, yo. 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 So let's go. What did I type? Let's go 3.3.3 as well. Let's see what happens. Can I put? Nope, it don't work. So let's see what happens with that. Shout out to Columbus. Yo, the bus in the building. 614 in the building. What's popping? Houston in the building. What's popping? Grandview. Shout out to Grandview in the building. What's up, man? Hey, 816 in the building. I see you. Houston, H-Town. So we can't get to 3.3.3 either. It looks like. Let's see what the lists know. The default. So we can get to R2. So for this network here, I thought I put a static route. Let's go back. Let's go back. Let's go back in time. So session and disconnect 1, disconnect 2, show host, and let's go back into R1 real quick. I want to check one thing in R1. just one thing in R1 before we go over to R3, because the issue is in R3. But I want to check one thing in R1 before we continue on. I want to make sure I put this route in there right, because what's got me tripping is this reply for this network was from my default gateway. Like, my default gateway didn't have a route. It's like, yo, I don't know what to do with this. So let's go in here and check this routing table on R1. Show IP route. Show run pipe include route. I'm gonna show y'all something real quick. When I put this network in here, I did a /32. So the only IP address that PCA will be able to get to, or that router 1 will be able to route for this network, is the network ID. So if you put the static route in wrong, incorrectly, it's going to affect what you can route. Because it's like, whenever you put a static route, it's like, yo, I only know about this route that you put in. Anything outside that subnet, it's not going to know. Even though you may have 192.168.1.2.3 or whatever, if you put in 192.168.2.0 and then a /32 like I did, it's not going to know how to get to that network. So what we need to do is remove this static route and then add in the correct one. So let's go in here and do a no. That's going to remove the static route and add a new one. Route. We may have to clear the router table. We'll see. And 0, 0, and so again, basic troubleshooting. Basic troubleshooting from the desktop of PCA. I was able to determine, like, yo, the issue is on my router 1, my default gateway, because my default gateway is like, yo, bang, I don't have a route. On the route to 3.3.3, it didn't. My response made it to the default gateway and it made it to router 2. So I know the issue is not at router 1. It has a route and it sends it either by static route, either by a dynamic route, or a default route to router 2. And router 2 is like, yo, I don't know. Or there's a firewall blocking, or there's going through an MPLS, or something where you can't see the routing, but you know, okay, we at least need to find here what's going on. All right, so that's that. Let's look at the routing table again. Show IP, route. Cool. Cool, we good. We good. We good. All right, so now let's exit out of here. And let's go into router 3. So show host telnet 192.168.33.1, and let's go into router 3 272. Log into router 3, see what routes we have here, and then once we configure the routing here, we should be able to ping from end to end and be good to go. So show IP route. Router 3 doesn't know any routes that are connected on router 1. So we have to go in here and configure the same static routes. It doesn't know about this network, it doesn't know about this network, and it doesn't know about this network. So although router 2 knows about all networks, router 3 still needs to know where to send everything to. So what we can do, since we're doing static routes, we'll do a static default route on this one. So let's go IP route, default route, all zeros, and make it the next hop of R2. And so now I should be able to ping 1.1.1 with no issue. I should be able to ping 192.168.1 with no issue. I should be able to ping 10.1.1 with no issue. And I should be able to ping 192.168.2.2. I don't even know if that's the IP address of that other device. Of course, that's my IP address. Man. It should be 1.2. So 192.168.1.2. Boom. So I could ping from router 3. From router 3, I could ping everything. So if I go into PCB, and we'll wrap up the lab, verifying PCA to PCB connectivity, and then we'll be out of here and all that good stuff. So show host, we're going into PCB, so telnet, and we'll go into 70, and I'll get to y'all questions in a minute. I'll see whatever's going on in the chat. So from PCB, I need to verify connectivity to everything. So let's just do all the loopbacks and this IP address here. So we'll ping loopback. Can you do that from user exec mode? Yep. So let's go 2.2.2. We're good. And let's go 192.168.1.2. Cool. Let's do a trace route. So trace route 192.168.2.2. Look at the trace, see how that comes back. And so by using a default route, I have full reachability. Again, I did the wrong thing. This is going to take forever. I'm just going to cancel that. We know the pings work. I put in the wrong IP address. This IP address doesn't exist. So this is just going to hop for 30 hops until it is done. And I don't feel like waiting, and I can't control Shift X to cancel it. So yeah, we're just going to go ahead and just call that a wash and realize that we had connectivity. And we'll go over to PC A and verify that we're good on that end. So let me do a disconnect. 1, 2, 3, and then telnet to 69, and boom. So we're in PCA. Let's do a trace route to 2.3. And this is going to verify from PCA to PCB full reachability, and we'll see all the hops that we actually encounter. So our first hop should be the default gateway. Man, this takes forever. All right, so the next hop should be R2. All right, and then the next hop should be PCB. Or R3 and then PCB. PCB. There we go. So we went from default gateway to this interface to this interface to PCB. So boom, boom, boom. So so the default gateway, this WAN outside interface to this WAN outside interface to PCB. So we have full reachability. We're good to go in our lab. Like I said, you can find this lab on Twitter. If you like this video, hit me with a like. Let me know in the chat. If I helped you, let me know. And if you enjoyed this live stream and you want to see it again next week, I'm going to be back regardless. But if you want to see me again, you can still let me know. If you don't want to see me again, you can still let me know. If it's something you think I can improve, let me know, because I want to provide you the best value possible. Before I'm up out of here, I thank everybody for tuning in. It's been going down today. I really enjoyed sharing this information, this knowledge. I hope you were able to soak it up and all that good stuff. And cool. Hey, thanks. I enjoyed it. Revenge of the Nerd. What's up, family? Yo, my man's in the building. Portland in the building. Clyde says, speed up trace command for the lab, real world. No IP domain lookup. That'll speed up trace? Yo, hold up, man. I thought that was just for domain lookup. My man! Hold on. That could be because I ain't have to. Yo, I learned something. Next week, we won't have to wait on these traces because my man just plugged your boy. Shout out to Clydesdale, Clyde, for coming through with the no IP domain look up on the trace routes. I never knew that. I learned something new today. Man, look. Yo, that made my day. If you stayed through the chat, if you ain't learned nothing else, know that not only does no IP domain lookup stop those DNS queries, it also speeds up your trace route. Real world. That's, shout out to you, fam. Y'all, I don't know what I owe you, but I owe you something. Man, look. That's what's up, man. Yo, shout out to everybody in the chat. I thank y'all for tuning in. Enjoy y'all Saturday. I'm about to catch up with my family, and I'm